Good afternoon and welcome to the CERIAS Security Seminar from Purdue University. Our speaker today is PhD student Wonjun Lee. His work is with Professor Elisa Bertino, and his topic today is detection and protection from denial of service attacks in grids by accountability agents. Wonjun?
Hi, good afternoon. My name is Wonjun Lee. I am working mainly with Professor Elisa Bertino. Today I'll be presenting about my research topics, detection and protection from denial of service attacks in grid environments by accountability agents. Before going inside, we need to specify three keywords. They are grid and accountability and denial of service. Three keywords mostly you might hear before. What is grid computing system? What is grid? Grid is the independent multiple clusters, something like resource nodes. So we call as a grid. There are many types of grid. So like a computational grid and data grid, and application grid, a visualization grid, cloud computing, many things are existing right now. Computational grid is mainly focusing on computational operations, while data grid is mainly focusing on managing and controlling the sharing the distributed data. Here is an example. Like a Pete, who is a participant of the Open Science Grid, we call the virtual organization, which links shared resources, perform multidisciplinary simulations like a NW Fluid Linux, which is like a computational fluid mechanics applications. He wants to run this program, but he doesn't need to copy all the input data from multiple sites to the local machines, or he doesn't need to install the application in local machines. He can only learn program A in A-state universities, like here, and the program B at B-state university by reading data from C-state university. What is accountability? Accountability is defined as A is accountable to B when A is obliged to inform B about A's past or future actions. If there is something wrong, A's actions should be traced back to the real entities and sometimes suffer punishment. Accountability is an important aspect of computer systems for assuring that every actions executed in the system can be traced back to some entities. Even accountability is very crucial for ensuring safety and security for a grid computing system. Because of the dynamic and multi-organizational nature of a grid system, which requires effective, efficient accountability system. But up to now, there is no comprehensive accountability system is designed. What is denial of service? This is an attempt to make a computer resource unavailable to legitimate users and target victims, in our case, located the servers located inside or outside a grid. So in this talk, we will introduce the concept of accountability agent, job graph, cover record, log sharing mechanisms, and accountability data collection strategies in two strategies. And we show types of distributed denial of service attack that could exploit the grid resource. Finally, we will show some experimental results about the performance of the system. This is the overall architecture of the accountable grid system. The one or more clusters belong to one resource providers. We call RP. And the one or two RPs belongs to one service providers. And there are a couple of service providers here. And the users can access grid resource by contacting service providers or directly to our resource providers. The entry point where the first access is performed we authorize the users based on some users attributes or by some access control mechanisms. Accountability agents. The original role of the accountability agent is to collect accountability data useful for accountability and to map users' activity and resource consumptions to real identities. Accountability agent is able to trace back to identity providers. If the identity management system, which such as Shibboleth, is employed in the accountability system that authenticated the users. Accountability agents are located at multiple places across a grid node based on the criteria to satisfy two strategies. And shares accountability data to maintain co-relationships. And they have also each own database at the locations. So to hold individual users accountable, we need accountability data. Accountability data are collected in two strategies. First strategies is we call job flow-based strategies. If you submit your job into the sea of the grid, the job traverses to somewhere, node to node. The entry node is different from the execution node. And as you might run any parallel jobs before, the one job is divided into too many jobs to be run in parallelizations. So which means job is divided into many sub-jobs and traverses along the nodes across different administrative domains. So the activity of each job is studied as a function of job's traversal in an initial point. And in these strategies, a viewpoint moves along with the job and reports to accountability agents. It is something like if you see the particle of the fluid, the fluid moves or traverses from location to locations. So it is something like you are going with the fluid. Wherever the fluid goes, you're going to go. That is the strategies. And in these strategies, agent tracks down job's whole life cycle from creation of the process to the termination of the process. The second strategy is we call the grid node-based strategies. In these strategies, agent is only interested in a given locations at a given spatial of time. In this case, the viewpoint is fixed. The grid is composed of many layers, like the fabric layers, connectivity, resource, and the collective, and applications. Something like OSI 7 layers, starting from the physical layer, data link, networks, or something like that. So if you focus, if you